So just to introduce our project, we built our own post and beam constructed passive house project in Albert Park, and we moved in last June. So this is obviously our own house. It's the first chance I had to design my own project after practicing for, say, 17 years when we started, about 18 on completion. Um, Over the time of practicing for other people doing all these houses and apartments, I had loads of ideas about what I might do when we got our own project. But of course, they're all theoretical until you get a site and you have a context and you have all of the challenges that you need to deal with on that particular site. And then there's budget. So we ended up buying a site that sort of crossed all my red lines. It had very limited access. It had no rear access, it had no opportunity for a kind of a garage or a shed. It was in a heritage area. And yeah, as you can see, it's a really sort of tight, compromised location. It's 4.85 meters wide. All our access on the project was through the front fence. So we're built right to the boundaries. And we also had stuff like fire rating, overlooking, things like that to deal with. So the types of project I've worked together with Rob on since I moved here in 2012, we've done Glu-lam projects, CLT, I've done prefab, SIP space systems, all sorts of LVL construction, things like that. So predominantly work in timber methods, and even in multi-res, Rob and I worked on the first couple of multi-res projects that were built and designed in CLT. So this is just some pictures of some of those projects in this current role and previous roles. Um, yeah, so that's what I love. I love working with wood, and of course, when it came to my own house, then I wanted to incorporate that into our own project, but I wasn't quite sure how. So then, let's take a look. Um, this is our ethos. When I started to practice in 2019, it's my second practice. I practiced for 6 years as an architect in Ireland before moving here, and that was more about a lot of heritage work, but also a lot of sustainable projects. By this time in 2019, I really just wanted to focus on working in timber. I believe that's the future, and I believe it has so many benefits and advantages over other methods of construction. So I kind of formulated this as a manifesto for our practice, and don't have to go into specific details of it here, but just love timber because it's renewable and it's beautiful. If we build properly in timber, it can last forever, and they bring real joy to people inhabiting these buildings. It's adaptable, it stores carbon. Um, it's supposed to make occupants calmer and improve their health. And as you can see in the picture there, people love to touch it. So any projects I do with timber, people come in and they instantly run their hands down it, and it just makes you feel instantly at home. So it's just a quality I love that I don't think you can get in any other material. For passive house projects, which is our other practice focus, timber is the ideal companion material. It's a natural insulator, so its thermal performance is excellent. It doesn't transfer a lot of heat or cold through the structure. It doesn't use a lot of energy in producing it, and it stores about 50% of its weight in carbon. So we always use certified sustainable sources. Um, Engineered timber then is the natural progression from that. We can do all sorts of amazing things in engineered timber, and anyone on this WoodSolutions webinar knows that. So we're all fellow enthusiasts in this material. We can flex it to design anything we want. It's an eco-friendly option. We can make it fire resistant. We can prefabricate, and yeah, so it just has really good qualities internally as well, with acoustics, warmth, and that sort of biophilic thing that we're striving for in projects. This is just an example I visited on a study tour last year. After I completed the house, I went to Scandinavia for a few weeks purely to visit timber constructed buildings and the latest projects in about 5 different countries in the Nordic countries. This is the world of Volvo, and it's entirely built out of Glulam, and you can see it's just a beautiful, lightweight, bright construction, and just really nice showcase as an example of what we can do in this engineered timber. Okay, so I put together a really simple 1 minute video just to introduce Passive House and how we can achieve Passive House. Essentially, there's 5 principles for Passive House, and I'll just let the video play and we'll see those. The first thing to do is insulate your project really, really well, minimize the thermal bridges, and then have good quality double or triple glazing. Make your envelope as close to airtight as possible and have a heat recovery ventilation system. Add renewable energy and add operable shading. And then all of those methods combined will get you a passive house. You can do it in any type of project at any scale, from houses up to large industrial and commercial and public buildings. So I've been working in Passive House, probably started about 14 or 15 years ago and certified in 2013. Everything we do now is Passive House. It's just a non-negotiable. We think it's the best way to build, and we think the outcomes are the best for the owners and for the developers as well. So if we watch this, this is a built example of this project in Kyneton that I again worked with Rob on the design and construction of this. These clients have moved in just last July. And of course, in Kyneton, you've got that cold weather in the wintertime, and you've got some quite hot weather in summertime. So perfect place to actually see a passive house that's orientated perfectly north and how that works in practice. In wintertime, we want to take as much solar gain into the project as possible to use that to warm our house up. We've got a heat recovery system running all year round, 24 hours a day. In spring and autumn, we want to have about 50% of the solar gain taken in. So we design our windows and our eaves to do that. And in summertime, we want to completely shield out that midday sun and, of course, the morning and evening sun as well. What's happening with the ventilation system is it's taking in cold air in wintertime from outside, and it's using the warm air inside to actually preheat that and keep that warm air inside the house. So I'll just pause this for a second so we can take a look at how that works. So when you draw through the heat exchanger, it's filtered and you provide fresh filtered air that's been conditioned to every habitable space in the house or in the building. And then in springtime, it's sort of pretty balanced, and then more so in the extremes of summer and winter. In summertime, then you get to actually keep the cool air in the house, use that to pre-cool the hot air you're taking in from outside, and then distribute that around the house. So in a 1 minute video that you can come back and look at again, I'll host this on our YouTube channel. You can just see what those principles are. So we've enacted all of these principles in this project that we're going to show you today, and we'll take you through that now. So ours is a Passive House Plus, which means it actually generates more energy every year than it consumes. So it's carbon positive. It's built in glue laminated timber, and we've tried to reduce our embodied energy in this project, and that's one of the reasons why we use timber on our projects. It's a very simple manual construction, and I hope by the end of the webinar today, you'll see that this is really, really a basic type of building. For the most part, it was built by David with an apprentice, Lockie, and he sometimes had another chap, Joey. I pitched in with lifting and stuff like that. But this is built with a builder with a nail bag and a hammer, and we used very, very simple manual methods. So you could employ this anywhere, but of course it's scalable to much larger construction as well. So this is our site, 4.85 meters wide. It's about 3 kilometers from the city centre and 350 meters from the beach. We're completely hemmed in by buildings, and there's a heritage overlay on the area. Now, we weren't subject to the heritage overlay, so we were allowed to demolish and rebuild. But you can see it's just a lot of cottages, very, very poorly constructed, no fire rating on the boundaries or anything like that. Coming into the site here, that's our only access. We're building to that boundary where the string line is on the right-hand side, and we're running all the way back out to the street. So as you can imagine, getting in any type of construction vehicle, getting deliveries, all of that, even just the sequencing and storage of the materials for this project on site was really, really challenging. So we had to think about all of those things in advance before we start construction, and keep working on that, and then adjusting the timelines during the project as well. So just going to talk about the design process and how this whole thing emerged. from my mind and becomes a reality. It's just a bit of a story about the project and I guess how I work and how that now manifests in this building I'm sitting in. So, uh, I don't, if many even people don't know it, Albert Park is just right by the beach, but it's close to Port Melbourne. So it has this really nice historical context. We still get ships arriving in and out of here, and the Docklands is just further up the river from us. So it's an active port area, but you've got this great industrial and maritime heritage all around us. We've got old docks and harbours. We've got all these old buildings with brick buildings with gable fronts and porthole windows and evidence of all that activity that used to happen here. Um, we've still got lots of timber-built docks and the remnants of some older ones as well. So I was just looking at that stuff around us and getting some cues and trying to get something that was appropriate to the context. Um, I was also thinking about where I'm from and what I love. This first picture is a Viking longboat. I'm from Dublin, and I never thought I'd leave Dublin. But kind of like the Vikings, I went overseas for one reason, and I ended up staying. So the Vikings came to Ireland, and they sailed up the River Liffey, and they stopped at what was called the Dove Linn or the Black Pool, and they pulled up their boats there. And over time, they liked it so much that they stayed, and they founded nearly all the major cities and towns in Ireland. So I've always loved boats. I've always loved that simple logic, the language of their construction, the just how they were built and the sort of the romance and the story of them. I wanted to do something really simple like that, that was evident that you could see the structure. Again, I've always really loved that. That's me with the blue eyes and blonde hair there growing up, and I've spent a lot of my childhood and a lot of my life kind of in and out of boats, living close to the water, and that's kind of driven the choice for us to live beside the water, and choosing this location here, which was compromised in so many other ways, but it had a great spot right beside the sea. I wanted our children to have that growing up as well. So yeah, I tried to think about that and how I could manifest that in this design for our own house. It was the first time designing for us and the stuff that we loved. And yeah, I get to do whatever I wanted. And yeah, I'll just show you how that looks. So yeah, this was the sort of visual thinking and sketching and exploration I was doing back at that time. And how would I incorporate that language of timber, the construction? How would I incorporate that sort of heavy look of those piers and ships and stuff into a house? Um, I kind of wanted it to feel like an arc for our family. I wanted it to look a bit like a boat that had been pulled up off the sea and onto this sort of safety of shore on the beach. I kind of had a bit of a joke about being fresh off the boat because when I first came here, people used to say that to me and question my experience about being fresh off the boat. And yeah, I really feel like this is home now that we've built one and we belong here and our family love it. So yeah, this is just a glimpse at some of the kind of design process in the early stages. So then through that, then we move on to a three-dimensional model, and we build this for all our projects. This is fully interactive. You can use a virtual reality headset and walk around. So we give this to our clients, and we let them and their family explore their project before we build it. But it's not just a fun thing, and it is, a cool design thing that shows us the light and the views and all that stuff. It actually has a really practical function. For a project like this, we really, really need to do a lot of coordination for structure and services. As you saw, it's such a tight site, and we're prefabricating everything, so it has to be perfect. Um, we shared our model back and forth with TGA engineers, and we incorporate their revised structural model. So what you see here as the gray flashing thing is actually the engineer's model superimposed on our model. And when it's flashing gray or flickering like that, it means it's perfectly aligned. So we know that we're okay to authorize the manufacture of this. So it's the old principle with timber of measuring twice and cutting once. So We've worked a lot with Rob and TGA on projects. They use a five-axis CNC machine. For our own house here, we did a fillet or round over on all the edges to give them a softness I wanted. Um, the entire project is built with a 2 mil tolerance, which is pretty amazing. And a real credit not just to Rob and his team, but also David the builder. Like David is a perfectionist, and I couldn't have asked for a better person to work with on a project like this. Um, I can't find flaws in the house, and yeah, so that's just something to think about. Yeah, coordinate up front and make it really tight. The engineered timber we use is a great dimensional stability, so we knew it wasn't going to kind of change character once we'd installed it and shrink and things like that. We also pre-oiled and sealed all the end grains. So pre-oiled all the elements and yeah, sealed the bases to stop water being absorbed. So in their factory, it looks like this. This is the elements coming off the machine. We get them to site. They've got the slots cut in them. They've got the holes. I'll just pause it there for a second. There's two types of joints that we've used throughout the entire project. So David, the builder, organized for the steel plates to be CNC cut, and that they're galvanized. They're simply dropped into the slots, and as I mentioned before, steel stainless steel dowels are placed in the place of what used to be oak dowels, and they're just hammered through the steel slot and back in through the hole on the other side. And that's the entire structure. There's no glues, there's no other mechanical fixing. Just a number of these dowels or pins are hammered through every one of these plates, and that's how the whole house is connected together. The timber is actually light enough that can be brought to site on a roof rack like that, except for the largest of the elements. Um, okay. And so we've used two types of connection, as I mentioned. We've got this one, which is the stainless steel pins driven through the plates. And then after they're installed, they're hammered home and counter punched or center punched so that they're actually below the surface. And then we plug the hole with the tapered timber plug, and then we just saw off the bit that's proud, and that's it. And then we just oil them again when it's finished. The other type of connection we had on the boundary side was these aluminium angle plates that we fixed into the face of the beams, and then we rebaited out the blind side of the boundary beams, and we simply sleeve those onto these angle plates and then fix up and down into those. So that's it. Two connections for the whole house, keeping it really simple. And you can see at the end there, that's the actual installed version of it inside the living space. And you can see the timber plugs that have just been cut back to the surface flush there. This is actually how those base plates look in reality. They've got the rods coming down. They're tied into the structural slab, and David located those by laser and leveled them. And the practicality of actually doing that on site, after the first lower slab was poured, he decided it was probably easier to locate those when the slab was wet and actually drive them down into the wet concrete and check the levels and location as well, just because the concrete pour is always a bit of movement and a bit of chaos and stuff. So afterwards, then the flanges get welded on, and we've got the slab edge rebate for the boundary wall panels. So somebody asked about the thermal bridge there. There is a thermal bridge here from the slab into the two steel flanges that come up, but remember, it's buried in a very, very substantial timber section, so it's right in the center of that. It doesn't actually come to the edges. We've added extra insulation, as you'll see, so it's always layering up the insulation. So even if you get a thermal bridge, you calculate that and you mitigate it by making it discontinuous. So this is how they arrived on site. So this is the largest member in the house, and you can see four people can carry that. We stacked them like this, roughly in their locations where we'll need them. They're all numbered as well, so we know which one is which. But it's a big, big jigsaw puzzle. It's a very tight site, so we had to keep those in locations where we weren't moving them repeatedly and then keep them dry. So the manual assembly is this. Um, we use this manual forklift just to winch them into position, and then when they're up, we just temporarily brace them, And then we drive home those pins. You can see here, they're just about to hammer home those stainless steel pins while it's being held upright. And that's the first couple of columns installed. We were really relieved. Somebody was asking in the questions about the tolerances. We designed and checked and rechecked and that. So that's how we reduced our mistakes on this project. We didn't have any big problems or any big delays because of all that pre-design checking and coordination that we did. So this is the actual assembly of the beams. They're just tied onto the forklift. The forklift has a counterweight on it, and they're just manually cranked up into position and then lowered down onto those pre-installed steel plates. And we just repeat the process throughout the ground floor. They get a real rhythm, and it becomes quite fast. But this is such a rewarding time now because you think for me and for the builder David and for Rob, we put so much time and work into this, and then to actually see it take place and take shape on site really quickly, it's just so fascinating and exciting. And then this is the second type of connection. So you can see we have the angles installed and we're about to sleeve over those boundary beams. And then this is after about, I think, a week and a half, maybe we've got the entire ground floor structural skeleton is assembled. And then we moved on to the first floor. So the practicality of the first floor, we actually installed boundary panels at this point because we won't be able to access them later. But to build the first floor structure, we lay down a deck of red tongue, and then we have a safe platform for erecting the second story. And this is the large section at the front. It's kind of like the idea of a captain's quarters or master's quarters just hanging out at the rear, the stern of the ship. That's that boundary beam being sleeved over the angles. And this is the typical cross member just dropping onto the steel plates. That's the actual steel plates just up ready for the beams. And there's the beams approximately in their position. So they're close to where they'll be assembled. Again, another few days just with good weather, and you can see the entire first floor, the shape of it starts to become apparent. And we stepped it down at the front here towards the bow of the ship just to tie in with the roof lines and heights and that kind of heritage streetscape that we have. We infill within the Glu-lam structure with conventional timber framing and fascias. So we're all working in timber. It's really, really simplified things. Because we were quite accurate, we could just pre-fabricate all of those box cutters and stuff. And then we get the sheeting and bracing onto the roof, and we can start to make that weather tight, and we can start to sort of lock up the building at that point. So somebody else asked me about the fire rating on the boundary. So I wanted to save space, but I wanted to have good insulation, and we needed to sort of be really accurate as well and tie in with this. So we didn't want to introduce another wet trade and to lose that space, and we didn't really want a frame system. Wanted to get something that was as good as possible for Passive House. So we chose these insulated panels that have a color bond skin on the inside and outside, and they have a core of rock wool, and that gives us 0-60-60 in a 100 mil panel. So this is how they're installed. On the ground floor, we just sealed off the base of them to stop any sort of water rising up into the panel. They're installed in a channel that has weep holes, and we have fire rated caulking. And you can see we have termite barrier beneath it and stuff like that. So that's installed in the slab edge rebate. And at that junction between panels and between the panels and the roof, we have an airtight junction strip installed as well. So we're using the panels as our airtightness layer. So they come on the back of a flatbed truck, all pre-cut to size. They're hoisted into position using this vacuum lifting device. So you're relying on that suction to actually keep it attached to the panel while it's being lifted over the house and over the neighbors. That's the panels installed, and we've used that as the air tightness layer with the junction tape on it. And at this point, we're actually ready to then tape up and seal the external membrane onto those panels as well. So we're taping from the ground structural slab onto the panels. We're taping from the panels to the next panels above, and we're taping also onto the timber frame. So we've got multiple layers of air tightness that we have. And then outside you can see we've formed up the parapets and everything like that. So you get a complete airtight and weathertight layer internally and externally. So at this point, we're weathertight, and we're starting to do the internal stud works and the insulated concrete screed on the ground floor. So this is when we start to see what the volumes, the character of those rooms will be like, what the views and light will be like. And we're moving on to making it completely weather tight and starting to get to lock up at this point. Again, just showing more examples of what that's like before we added an internal stud of additional 90 mil high density insulation inside those panels. So again, thermal bridge with the panel, but we add more insulation to mitigate that. So outside, I had this kind of language of a hull, which is sort of panels. You can see the bolts kind of resemble rivets and stuff like that. Um, I use the portal frames to sort of subtly divide the house into these zones, so it's not this long tunnel, and it also draws your eye up and to the perimeter of each room and up to the ceilings as well. It becomes this sort of natural thing. It defines the dining area, then stepping through into the kitchen, and then you're looking down into a living area where the ceiling rise or the floor steps down. You get a higher ceiling. I kind of had this idea it was like a diving platform at the back, step out into the garden. So we highlight all that timber then by having a recessed LED trough just to pick out that golden glow that you get from that naturally oiled timber that we have inside. So at this point, we're ready to start installing a low CO2 concrete screed to the entire ground floor. So I'll show you that in a moment. And that's the screed there with all of the edges and upstands are all further insulated. So we're trying to reduce thermal bridges throughout the whole project. Okay, so the passive house principles insulation is actually a pretty cheap one, but you've got to make sure it's continuous. And if it's not continuous, then we typically add a second layer to cross that as well. So I'll just show a video of how we achieved two of the principles being insulation and trying to, you can't eliminate thermal bridges, but you try and reduce them and then mitigate them where they exist. So at the slab edge, we have that rebate, and then we've added a screed. We've got continuous insulation on all the boundary wall panels. And if I just pause it there, you can see we're adding this PIR insulation around the screed and around any penetrations that we have as well. And that's the insulation ready for install to the ground floor underneath the screed. Just about to pour at this point, and that's it installed. So we've insulation everywhere. And we've added 90 mil stud inside all of those boundary wall panels. We've made sure that there's nowhere where you've got continuous timber that you don't have insulation or multiple layers. And the timber itself gets factored into the U value calculations. With timber being a natural insulator, actually you're allowed to have a certain proportion of timber. So yeah, through the project we just put as much insulation as possible. To give you some ideas of examples, our screed had R23.5, the boundary walls had R5 insulation, the stud walls had R4, the sloped roofs had R6, and the roof terrace had about R4.5. So the next slide looks at two more of the passive house requirements. We're looking at the glazing that we used, and we've added external operable shading. So our glazing is triple glazed with low E glass. It's alu-clad timber. They're all tilt and turn. Multi-point locking. There's electronic access on the front door. So thumbprints, key codes, remote access, things like that. The glass has a privacy tint, so you can see on this screen when it's not lit internally. So the study's lit internally, you can see somebody just about inside, but in the daytime you can't see through this glass, which I quite like just on the front. So we don't have to have blinds. There's electrically controlled shading on all the north-facing windows in this. We've got double seals or triple seals around all of the opening sashes, and we got porthole windows, which was pretty fun. So they arrive on site like this. There's a portholes, and some of the glasses like this, we've got kind of reeded and frosted glass in the courtyards. We've got remote operators on high level windows and electrical winders, tilt and turn mechanism like that, so it can be left open for ventilation, but it's safe. We put the windows in, we foam around all the joints, and then we tape up those joints as well. And you can see just like simple practicalities, so just French doors, but we've got portholes that open, and that's them installed as well. All the north-facing windows have these operable shading to reduce that solar gain, so we're not overheating in summertime. So that's just a brief look at the windows. Um, and the rest of the passive house requirements, we have air tightness, heat recovery, ventilation, renewables. So we've shown you some of the seals we've used externally and internally, and we've also got tapes, foams, and caulking. You actually end up using a lot of that, and that takes up quite a bit of time and labor and just attention to detail in the project. Um, we keep all our services inside that airtight layer wherever possible. You do get some penetrations, but you have to tape and seal those. We have a heat recovery ventilation system we'll show you. We're all electric. We have a heat pump for hot water, and we reverse cycle air conditioning for when we need it for the extreme heat and extreme cool. We have a 6.6 kilowatt PV system with micro inverters. So, yeah, just looking at this air tightness seals, the external membranes, and you can see again another example of just foaming and sealing around those windows. Then you're adding an internal airtight membrane, taping that tight, keeping the surfaces inside, taping the glazing onto the external membrane so you get that continuous weather tight layer outside. We've used a Zender heat recovery ventilation system. And then you've got these large ducts for the internal and external uh, air intake and exhaust. And then in the house, when you're roughing in, you've got to allow for a lot of services with a passive house. So you can see here we've got all of this ductwork, and one of these ducts supplies air to every habitable room, and it exhausts air from every wet room and kitchen. And that's using that kind of latent heat in the steam and water vapor to actually heat up the air that we're taking in from outside in winter and doing the opposite in summer to keep it cool inside. So that's what the system looks like installed in our laundry room. And this is our heat pump hot water system with an external heat pump mounted on the wall. And then up on the roof, we've got a multi-head split system. That's the air intake for the fresh air for the heat recovery ventilation. And we've covered our roof in as much solar as we can to try and maximize our energy production. So as I said, we're producing more than we use. The bills that we get in wintertime are really low. And yeah, we've got everything set up. So the hot water, all of that, appliances and stuff, we try and use them during the daylight hours as much as possible. So we took it to the next level kind of with the stairs. Rob had a load of glue laminated timber elements left over from a previous project that he gave to me as free as a jumble puzzle that I could make into a stairs if I could use them. And then they machined them for me into the pieces. So initially we'd engineered this so that the handrail would be the structure, that each step would bear on the next, and the handrail would allow them just to cantilever all the way down. But the practicality of installing that meant we needed to add a string just to make it simpler for the builders. These steps are solid pieces of Glu-lam, and they were too heavy to just do that cantilevering construction. So, but it turned out really, really beautifully. I love designing stairs, and I got to go a bit wild with this one. I wanted it to look like it had been out of a luxury cruise liner with a few little special touches on it as well. So this is just some of the concept sketches, what it would be, how it would look like, how we'd fit it together. And you can see I was working out many ways to figure out the handrail. I wanted it to have a lucky shamrock on it, like the rugby logo for Ireland, so that when you're going up the stairs, you touch that and it brings you a bit of good fortune. And that was sort of the drawings that we again shared back and forth with the engineers so they could actually manufacture this and the builders would know how to assemble it. So they came on site in large chunks like this that were numbered. We oiled them because we weren't going to be able to access them that easily once they're installed. They're bearing onto that column in the center and the beam that's shown there. And then you can see it's really starting to look good even during the assembly. That's just, again, manual installation, manual tools. This bit gets covered up, but yeah, it's all just done in timber with hand tools, and that's how it looks. I've separated the column off the face of it. We've curved the handrail, we've curved the edges, got this nice post projecting up in the center. It's quite complex. There's our lovely shamrocks as you ascend and descend the stairs. I'll just show you really quickly what it looks like. So a little walkthrough of how the living spaces look at the back. of the house. Yes, so this is just coming in. You can see the portal frames doing as I described. It's creating these sort of subtle zones between the kitchen, living, and dining areas. And you can see brought in as much natural light through a couple of light sources as possible. So we've always tried to achieve dual orientation through it. Um, yeah, we wanted to have all those curves and those warm materials throughout the house as well. So yeah, that's the alley-clad doors, separating living, dining, dropping the levels down as we move through the rear of the site so the ceilings get higher. Okay, and then I think my last slide about this project is just a very quick slideshow. It just gives you a brief glimpse into some of the other zones we haven't seen. Yeah, it's more like the laundries, circulation spaces, bedrooms with the cathedral ceiling. We built the bed out of the leftover from the Glulam. So that's just the view up on our roof and then finish. I'll just do 1 minute bars just to show just some examples. I went on a trip up through Scandinavia and I've seen they're doing some amazing stuff up there. These are entirely built out of engineered timber and they're apartment buildings. So there's no concrete built or in these above the basement level. That's in Stockholm, and they're building a whole quarter of the city. It's lightweight because it's being built over existing rail and road tunnels underneath it. This is another similar thing. These are modules that were prefabricated and all assembled into apartments in Stockholm. And this one is in Oslo. It's a multi-purpose commercial building. It built in CLT. This is a beautiful one I saw in Glulam in Copenhagen. It's just the sports center. Jorn Utzon, who designed our Sydney Opera House, this is his last building he built in Denmark. Again, another person who came here but didn't stay. And then I wanted just to finish this with the same sort of idea of a boat and timber. This is one of the nicest things I've ever seen. It was an ecumenical chapel in Turku in Finland, built out of Glulam, and just showcasing that kind of magic and the beauty of what you can achieve in Glulam timber. Well, thanks everyone for listening. So I'm going to hand over to Rob now to explain a bit more about the engineering.
Thanks, Niall. Great introduction to a great project. As Niall mentioned, we're involved with numerous projects over many years, over at least 10 years now, from commercial to residential to passive house. And with those principles of passive house, we've been able to come up with systems that achieve the requirement of thermal bridge and not having those type of issues in these types of structures. My presentation will be more an engineering review of post and beam and then talking about Niall's project and specifics towards the end. I represent TGA Engineers. We're consulting engineers. We have over 40 years or 50 years now with Tim and myself in terms of structural design, not only in timber but also in other materials, where we achieve great outcomes in buildings. As mentioned earlier, my specialty is in timber structures. I've designed large portal frames to multi-story in timber, as well as residential, which is our primary work. But we have a great love and passion for timber type structures. I also represent another company called Specialised Timber Fabrications, where we provide fabrication services on projects where we know we can provide a specialty type system where other companies out there are unable to provide that. Moving on. Yeah, so today's presentation, I'll give an overview of post and beam construction. So we'll talk about the structural system and how it um, is different to what's our traditional construction or what's accepted as standard construction in Australia. We'll talk about stability of systems. It's got some inherent stability, but may require additional stability. Material availability, glulam or sawn sections. Dimensional stability, which is a very important aspect to review during these kind of structures. Fabrication, techniques that are available, connections, and then site-specific engineering for this particular project. As Niall mentioned, we were involved early days on this particular project, so during design, trying to take into account the aesthetics and what he was wanting to achieve as a final project. And then with that in mind, looking at connection types, stability of the structure, as most modern structures, the downstairs is a quite open plan section with a large fully glazed end walls at bottom and as well as first floor. And that's typical of what happens nowadays with modern architecture. And then looking through to the final outcome. Post and beam, as the term suggests, is effectively just columns and beams, and they can be of many forms. They don't need to be in a rectilinear system. They can be other forms that provide that kind of appearance using timber. And generally, it's an exposed timber application. That way, they're utilising the material, but also expressing the structure as well. It can be used and it's commonly used in commercial application, post and beam, and usually in heavier sections to achieve a fire rating. It has an inherent fire rating resistance based on the bulkiness or the large section sizes that are available, and that's due to the char rate of timber. So, you can have traditional glulam. The middle one is an LVL structure that we glued up into various sections, and then, you can have heavy loads such as libraries and those kind of structures sitting on the floor surface. It's commonly used with CLT nowadays to achieve a floor plate, and they seem to work very well in that system. Post and beam is probably the most common form of construction historically, so it's been around for ever since medieval times, I suspect, where traditional joints of mortise and tenons and timber dowels and all these other types of handcrafted and bespoke type joints that are used to achieve a structure. And still some people build in this form in the old style, but also there's the newer, more modern appearance looking wooden dowels, bearing joints. So a lot of it you can see there is halved onto the column to achieve some bearing, and that's always the most efficient way to achieve a joint is to actually have it sitting on a bearing seat. And then there will be some inherent stability based on certain aspects of the type of structure, which many may not realise that that's what's providing stability. Modern construction, we tend to use large screws and modern brackets, but also use CNC machines to achieve a nice clean look and also achieve a very efficient fabrication and installation of a system. The bracketry can be hidden, as in dowels or dovetail type joints, so therefore by providing a very clean and neat looking structure. So stability can be provided by partial portalization, which I'll talk a bit more along the way, but also braced walls as well as other systems. And these are some of the new modern forms of post and beam, which are coming along and look quite neat and tidy and express the timber in a very unique way. Stability of structures, and many may not realise this, but generally our post and beam structure, the knee, what we call a knee brace, as you can see on that middle picture there, provides the stability to a frame. So that method there, it creates what we call a moment joint, and that way it holds it together as a safe and stable structure. The image on the left is what we call a hammer beam truss. So in terms of providing stability, you can see in the actual system there a triangulated truss system that then connects into the columns. The truss system itself provides the inherent stability by providing a lever arm to the column, in terms of engineering. So that way you provide a natural, and that's why these structures can be very large and very open span, especially in a lot of old churches and old building type structures. And the image on the right is a combination of all those to create a barn type structure, or which would become a residential type system. And if the opportunity does arise, you can also utilize internal walls that become bracing walls or shear panel walls through that. In the more modern type connections, we try to aim for clear spans with no knee braces or truss systems. So, a partial or full moment frame can be developed through the joint, as you saw earlier with Niall's photos and images there. We created an internal system that provided steel plates, and that then gave us the ability to achieve a moment connection in the sway frame direction effectively. And they're good for fully glazed end walls. You don't need internal knee braces hidden, so the dowels can be punched in, expressed, or covered with plugs. Also, you can express the bolts if you wish. In some certain circumstances, that can be done as well. And also, we've done connections where we've used large diameter and length screws through the beam into the column, and that's only suitable for light type moment connections. In this instance, we're also able to provide a moment base. So in timber, the sway actions are usually governed by very large timber sections, and to try and reduce the timber sections, we use a moment base. So you'll see going forward that we had some connection plates that were cast into the slab and then welded plates to achieve that moment base. Material availability. Glulam comes in a variety of species, so we can softwood or hardwood, and they can be laminated up into various depths and sections. So it's an unlimited almost supply of material in terms of length, dimensions, sections, and also species. So through there, we also have some imported material. We also have done residential with LVL. It's a more economical system, provides a more plywood finish rather than a laminated finish. And Glulam and LVL being a seasoned product prior to lamination is very stable. You can also apply termite treatments to specific elements if required, and there are a number of companies around Australia that provide clear treatment. So most treatment for termites will come out with a pigmented finish to identify that it has been treated, but there are a number of plants around that provide a clear finish, so it doesn't impede on the actual natural colour and durability or natural appearance of the timber. And once again, refer to each of the suppliers in terms of their product availability. So there's a good number of available products around. Or you could also do it from reclaimed or sawn timber, and they come in very large sections. So in a development or a project like Niall's, it was probably not the appropriate type of material due to the dimensional stability, but also the accuracy we needed to go to. But they're still available. Dimensional stability, as timber is cut from a log, you can see that in that bottom right-hand picture there, that depending on which portion or which section you cut out of the log, you have dimensional movement, and we have to take that into account. So using a Glulam or section would help reduce those dimensional movements, and also checking as well. And in some instances, you could get up to 10 to 20 mil movement if it was a green section. So a seasoned product is the ideal product to use in this type of system. It also reduces twist and bow. And these are the kind of things you would have to deal with. So by using Glulam and engineered timbers, we reduce and minimise our checking and dimensional movement. Fabrication, the old school, which we still do a little bit ourselves, using heavy saws or chisels. Very labour intensive, but in some instances the CNC can't get to some of these joints, so we have to do them manually. But it's still an option at the moment. And some companies out there, they still do it in this form. But the modern techniques, CNCs can achieve quite neat connections in a very efficient time. And then also detail ends of rafters with corbels and all sorts of details that would require a very large, skilled workforce. Connections come in prefabricated bracketry and screws, hidden plates, visual plates. So it all depends on the structure. So if, in this case, we had to use hidden plates that provided a moment action, and some of these connections don't give us that moment connection ability. So, but there's all still useful connections in post and beam systems where we don't need to achieve moment connections. So, and very efficient. And once again, you can go to your traditional, and still used in some instances as traditional connections. Site-specific engineering. So this particular site was narrow and long, so challenges in terms of erection, so keeping it to manageable pieces, as Niall had shown in his video. That was a crucial thing to look at. Modern design, so rear is open plan, so we had no real walls for probably 2/3 of the building at the rear, at lower ground, but also in the upper floor we also had a series of open plan areas as well. Fully glazed end wall, so we had a portal frame system at the rear, which was slightly heavier than the main frames, and also the cathedral roof, which was a cranked portal or cranked Glulam beam to achieve that. Aesthetics, so we had to maintain the type of structure, and the 3D images and the model developed gave us a great understanding of how it would look and with the section size. And some of the section sizes may have been a little bit larger for aesthetic reasons rather than structural reasons. Neat and connections that aren't exposed. That was a definite driver on this particular project. And also, looking at passive house criteria, so removing thermal bridges, etc. High wind, even though he was protected at low level, the upper story was open to the wind, so that coming from the bay, so we had to ensure that the stability of that upper section, and then that translated down into the lower floors, was taken into account. Structural engineering, typical layout generally. But more so, this is the base connection detail where we casted in a steel plate and then we welded the 75 by 6 mil fins in situ to within a high degree of accuracy. That way we were able to achieve a moment base, which reduced our sway in this particular instance. Simple connections for the ridge, a steel plate that was laser cut and assembled on site to achieve that neat apex connection, as well as on the left there, a transition from ground to first floor beam to upper story column as well. And as you can see, one of the frames was typically first floor, and then we had 2 cranked rafters or ridge beams that achieved a lower and upper roof in the upper story area, and with a void underneath. So by achieving a cranked or moment connections in those ridges, we're able to achieve these types of appearances. So yeah, so that's from my point of view the structural aspect of the building.
Look, we've come to the end of the webinar, so we won't have time to take questions. But between yourself and Rob, I could see with the questions that were coming up that you've answered the vast majority of them anyway. So I'll just finish up on the for today's webinar. So as I mentioned at the beginning of the webinar, you can access previous webinars through the WoodSolutions website. So today's webinar should be available within the next week. So you can just log in to go over some of the specific details that you may wish to have a review of. Look forward to seeing you at the next webinar next month, and enjoy your day. Thanks so much, and a thank you to our presenters, to Niall and Rob. Thanks so much.